So in this video, we are going to discuss about the problems on Zener regulator. So the first problem is find the maximum and minimum Zener current flows for the given circuit. So the given circuit is here the input voltage, it varies from 80 to 120 volt, and the Zener voltage here is 50 volt, and the output resistance is 10 kilo ohm. Okay, so this is your RL. Okay, so they are asked you to find the minimum and the maximum Zener current. Okay, so this is your IL, this is your load current, and this is your Zener current, IZ. Okay, so what is my I? I is nothing but IL plus IZ. Okay, so if I substitute, this is your 80 and the voltage across this one is 50 volt. Okay, so 80 minus 50 divided by 5k. So what is 80 minus 50 divided by 5k? 80 minus 50 divided by 5k is 30 divided by 5k. That is nothing but 6 milliamps. Okay. So this is your I. Okay. So if I substitute 120 minus 50 divided by 5k means it is nothing but 70 divided by 5k. That is nothing but 14 milliamps. Okay. Okay. So how to find IL? So IL is nothing but the voltage across this one is 50. So 50 divided by 10k. So that is nothing but 5 milliamps. Okay. So I have find out the value of I. This is your I, right? And I need to find the value of IZ. So what is IZ? IZ is nothing but from this equation, IZ is nothing but I minus IL. Okay, so you substitute this value 6 milliamps minus 5 milliamps. That is nothing but 1 milliamps. And if I substitute 14 milliamps minus 5 milliamps, I will get 9 milliamps. So this is your minimum Zener current, and this is your maximum Zener current. So let me go for the next problem. So this is your circuit given. This is 12 volt and R. This is your Zener diode, and here the resistance which is varying, load resistance which is varying, and it is given it as 7.2 volt. Okay. So the load current, that is IL. Since the resistance is varying, IL varies from 12 to 100 milliamps. Okay. So they are asking about find the value of R. What is the value of R? And they have given Z minimum. Z minimum is equal to 10 milliamps. Okay. So we know that this is your I and this is your IZ. So what is I? I is equal to IZ plus IL. Okay. So I can write this is nothing but IZ minimum plus IL maximum. Okay. So what is IZ minimum? IZ minimum, they have given it as 10 milliamps. What is IL maximum? IL maximum is 100 milliamps. IL minimum is 12 milliamps. IL maximum is 100 milliamps. So you will get 110 milliamps. This is your I. Okay. So 12. So I can write 12 is equal to I into R. I is nothing but 110 milliamps into R plus 7.2 volt. Okay. So I can substitute 12 minus 7.2 divide by 110 milliamps. That is your R. So if I substitute, I will get the R is equal to 43.5 ohm. Next, third problem. So VZ value is 18 volt. Okay. So the voltage across the load. Okay. So VL is nothing but 8 volt. As long as IZ is maintained between 200 milliamps to 2 amps. So IZ minimum value is 200 milliamps. IZ maximum value is 2 amps. Find the value of series resistance or so that E0 remains 18 volt while input voltage EI vary from 22 to 18. Okay, so this is your circuit diagram. This is so this is your EI, which is varying from 18 to 22 volt, 18 to 22 volt, and this is your series resistance, and Zener diode value is 18 volt, and this is your RL, and this is also 18 volt, right? This is also 18 volt. Okay, so find the value of R. Okay. Yep. And they are given the RL value is 18 ohm. Okay. So if this is 18 ohm, is the current flowing through the IL is nothing but 1 amps. Okay, so this is your I and this is your IZ. So I can write I is equal to IZ plus IL. Okay. So you can substitute sorry, this is 22 to 28. Yeah. So if I solve 22 minus 18 divide by R, I will get one current, right? Likewise, I is equal to 28 minus 18 divide by R, I will get one current, right? So I can substitute this one. Okay, so if IL is at this minimum, this is IL maximum, right? So this value is 1 milliamp. So this may be 200 milliamps plus 1. Okay, or it may be I is equal to 2 amps plus 1 amps. So this is equal to 3 amps, or it may be 1.2 amps. Okay, so the I value. So you substitute here. So R is equal to 22 minus 18 divided by 1.2. Okay, so if I substitute this 22 minus 18 divided by R, you will get the minimum value. So if I substitute 28 minus 18 divided by 3, I will get the maximum value, right? So if we solve, we will get 6 divided by 1.2, and this is also 8 divided by 3. So 10 divided by 3. This is nothing but 3.33 ohm, and this one is 4, right? 4 divided by 1.2 is 2 divided by 0.6. Okay. So this is also 3.33 ohm. Okay.